This is SolidWorks. This is the 3D modeling tool that we use to design all of our robots. At the very beginning of build season, everybody puts all of their ideas up on a whiteboard, and we vote on which mechanisms we think will work best. Then we start doing prototyping in the real world. While the mechanical team is doing prototyping, the CAD team is doing what we call Crayola CAD. In Crayola CAD, we throw big blocky shapes into the 3D modeling program to see what mechanisms would fit where, how the ball's going to move, and especially for this year's robot, this is a very quick and early representation of the arm, and we were able to play with the height and length of the arm to make sure that it would hit all the positions that it needed to. After Crayola CAD, we get a little bit more in depth. We go to more of a final CAD. This is a side plate of our drivetrain. We start with a sketch. We put in all of our wheels, belt lengths, and everything that we can't change. From then, we start sketching in metal. This is a very backwards approach to what you would think you would design. We put in our wheels and our motors first because we can't change those. Then we stitch the metal around it. This allows us to create very lightweight and efficient designs. Then, if we go back in time, we start by extruding our parts. So we have this big block, and then we start putting holes in. So there are some gearbox holes, some more mounting holes. We start putting in cutouts, everything we'll need, and then the final step is converting it to sheet metal. We use sheet metal because it's very light and strong, and we can have it manufactured very quickly. In SolidWorks, we use what's called the Convert to Sheet Metal tool, which takes this block, you select the faces you want, and it pops them right into sheet metal, and the best part is you can flatten it. Just like that. And that's what the laser cuts. After that, all the parts get bent on the press brake, sent back to us, and we assemble them. And then you have a robot.